Exercise 8.1 at Excel, Pure Maths 2 IAL. Okay. This is regarding integration. Do you know what is integration? Integration is just
Yeah,
opposite
it is
derivative, right?
yeah.
Suppose I have y and I need to find the gradient. What will I do?
You'll differentiate.
I will differentiate. So if I differentiate, I write this as dy by dx, correct?
Yeah,
Okay. If I want to go back to my function, what will I do?
you'll integrate it.
You will do anti-differentiation, or I would say I would integrate it. Okay. Suppose my function is 3x squared. If I'm doing the derivative, what will I do?
You'll do 3 into 2, which is 6,
You will
6x,
multiply with the power
and
and
minus 1.
minus 1. So this becomes 6x minus 1. So it's dy by dx. If I want to integrate it,
Miss, it becomes 6x to the power of 1.
I can integrate the derivative, the gradient.
Yeah,
Okay. So we write it as integrating the derivative, and what do we write next to it? With respect to x.
mm,
Okay. So
yeah.
how do we do it? First we
We'll
decide
add 1.
it is in the indices form or no. Okay. After that we add 1. So minus 1 plus 1.
Miss, how did you get minus 1? It's supposed to be 1.
Okay, sorry. So we add 1 and we divide it by the new power. We already have 6 and then we add a c.
Mm.
We add a c, what does it denote?
It's a definite integral.
It is an indefinite integration.
Yeah, indefinite.
Okay, because we always add a c because we do not know whether when you were differentiating the original function that did it have c or it did not have c. Okay, because when you differentiate, the c eliminates, the c goes away, the constant goes away, right?
Yeah,
In this function it was 3x squared, so it did not have a c. We know it over here, but there may not be chances that you know the original function. So whenever you're integrating, you are always going to add c.
right.
So this is an indefinite integration. So if you have to find the gradient, what are you going to do?
We'll differentiate.
If I want to find the area under the graph, what am I going to do?
Area under the graph.
Yeah,
So we'll use integration.
you're going to use integration. So integration is basically used to find areas under the graph. Okay. And if we have a certain limit, the integration that we do is called the definite integration. Okay. Say, for example, okay, the definite integration or indefinite integration, you're going to integrate it as normal. Okay, but the only thing is that we will not have a constant c added. I hope you're with
Yeah.
me. So if this is there, this is the,
Integration sign.
what is this known as?
Upper and lower limits.
So this is the upper limit and this is the lower limit. This would be my derivative and I have to integrate it with respect to x. Okay.
Yeah.
Okay. If I have to integrate this with respect to x, I call this as b and I will call this as a. This is which
Oh,
limit?
upper limit.
Upper limit is called b, lower limit is called a. We
Mm.
do the integration as normal. How do I integrate this?
Integrate.
How do I integrate it? Suppose I have to integrate 4x cube Upper limit is 5, lower limit is 3, and I write dx. How do I integrate it?
Okay, so you're going to add 1 to the power.
Hmm.
So 4x to the power of 4 and then divide it by 4.
Okay. The only difference over here is that here you have your limits now.
Hmm.
Okay. So since you have your limits, what you're going to do is you're going to have these box brackets around it. And when you have the box bracket around it, that means it's a definite integration which has limits and you are not going to add a c. Whenever you close it with a box bracket, you're not going to add a c. Now what will you do? You will
Now,
always have two brackets
hmm,
in between with a minus sign.
okay.
What you going to do?
Are we going to plug in the upper and lower limits instead of x?
So my upper limit is 5, my lower limit is 3, and say it was x4 over here. Okay?
Hmm.
I'm going to plug in instead of x, I have to put 5 raised to 4, okay?
Hmm.
Minus 3 raised to 4. So what is this going to give me? 5, 4,
540,
5 raised to 4 is what?
625.
Minus
3 raised to 4, which is 81.
what it comes up to?
544.
544. Okay, you have your calculator. In your calculator, you would see this below the menu button, an integration with a plus and with a upper limit and lower limit.
Yeah.
If you insert it with the function, you would get this answer. Try to do it with the calculator. I'll wait for you. Okay. So when you do it on the calculator, okay, this would be your upper limit, this would be your lower limit. 5 is the upper limit, 3 is the lower limit. If I want to use it in the form of a formula, I would say I'm integrating B, A, okay? I'm finding the area under the curve of a f dash x, that is the gradient, with respect to x. When I integrate this, what am I going to get? F of x.
Yeah.
Okay, I'll get the function. So it would be actually f of b minus f of a.
Hmm.
Are you with me?
Yeah.
Okay. You have this sum over here. Can you just interpret this for me? What does this mean?
So, like, do you want me to solve it out?
No, first explain me. What does this mean?
It's a definite, I mean, it's an indefinite integral because it has no limits. And then we need to
What is this?
integrate x to the power of n in respect of x.
What does this mean? What is this?
This is the f of x, f
Okay.
dash x, and then dx in respect to x.
With respect to x. So this is the sign of the integration.
Hmm.
This is the expression that has to be integrated. You can use brackets to separate it. And this tells us that it has to be integrated with respect to x. Okay. When you're integrating, what is your first rule?
What is the first rule?
It should always be in the indices form.
Yeah.
Okay. Second
Hmm.
rule.
What is the
Don't
second?
integrate each term separately.
Okay.
Third rule.
What is the third?
This is definite or indefinite.
Indefinite.
So you will always add a C.
Yeah.
Okay. So when you're
Hmm.
integrating, what are the rules you keep in mind?
We need to integrate each part separately.
First, indices.
Yeah, first indices.
Then
Then integrate each part separately
add a C.
and then add the C.
Again, three rules.
First, it should be in its indices form. Then we need to integrate each part separately and then add a C.
Okay, fine. If I have the integration with defined limits, okay, this is which
Hmm.
limit?
Upper limit,
This.
lower limit.
Okay. In that case, we will integrate it as normal and I will put a boxed bracket. If I'm putting a boxed bracket, do I need to add C?
No,
No.
because it's a definite integral.
Then what will I do?
You'll do
F of B
B,
minus
yeah.
F of A. This always has
Hmm.
to be a minus sign. You'll always put two brackets and you'll do
Yeah.
F of B minus F of A. I'm giving you time. Integrate this with with defined limits. Share your screen. So this is another example. Okay. You given that P is a constant, you need to integrate 2px plus 7. Remember, P is a constant, 2 is a constant. So this entire term 2p is a constant. Plus 7 with respect to x is equal to 4p square. That means they're telling you that when you're integrating this with the set limits, the answer that you're going to get is going to be 4p square. Are you with me?
Yeah.
You have to show that there are two values for p and find these values. Indirectly, they're asking us to solve for p. Okay?
Hmm.
So we will
Yeah.
solve for p. What is our first step? What is our first step?
We need to write everything in indices form.
We need to see if it's in indices form. It's there in the indices form. We wrote the question out. Then we are going to integrate this in our box brackets. I will have my b, the upper limit, and the lower limit written like this.
Hmm.
Entire 2p is a constant. How do I integrate this?
2px to
Increase
the
the
power of
power of x by 1 divided by the
divided
new
by
power. Increase the power of x by 1 divided by the new power. What I'm going to be left with is px square plus 7x. Now what will I do?
now you'll do f of b minus f of a. So
I do f of b minus f of a. So
mhm.
I have my first bracket, that is px square. I'll write it as p 5 square. I have the bracket x, it will be written as
7 to the power of 1
this would be p5 square
plus
plus
7
7
into 5.
5. And what would this be? It's going to be p1 square plus 7 into 1. Yes?
Yeah.
When I solve this, the answer that I'm getting is 25p plus 35 minus p plus 7. I hope you're with me.
Yeah.
I'll solve this further. I hope you're solving alongside. you're going to get is 25p minus p plus 35 minus 7 plus 28. Okay? When I'm integrating this, I have got this answer, and they say when you integrate this, whichever answer you get, this is your answer. This is equal to 4p square.
Yeah.
Okay, this is what the question says, and they're telling us that find the two possible values for p. So I would say 4p square minus 24p plus 28 is going to give me 0. I'll use the calculator, go in the polynomial function. Now this becomes a quadratic equation. So when I put this on
Miss,
the
hold up.
calculator,
It should be minus 24p minus 28.
minus 28, yes. So when I put this on the calculator, I get p plus 1 and p minus 7 is equal to 0. They want two possible values for p, so I would say my p is equal to minus 1, or I would say my p is equal to 7. So when we're doing integration, either I have an integration of the f dash x with respect to x. Okay, if there is no limits over here, it is an indefinite integration, and if I have the limits over here, this is the definite integration. I hope you're with me.
Yeah.
Okay, so when it is definite integration, I know the limits. I know the limits of the function, right?
Yeah.
And integration is used to find the area under the curve. That
Hmm.
means I am finding the area between the curve and the x-axis. I want
Yeah.
to find the area between the curve and the x-axis, and my limit would be a and b. When I do integration of a definite integration, I would say my limits is b and a, where b is the upper limit, a is the lower limit, and we are finding the area under the curve. Okay, the y is equal to fx, so I will have f dash x, and we are finding this. The area under the curve, where b is our upper limit and a is the lower limit, where it cuts the x-axis. Are you with me?
Yeah.
Okay, but sometimes they do not give us this a and b. Let's take for an example, find the area of the finite region between the curve with the equation this and x-axis. So if I see over here very clearly, how does this diagram look like? This is my x-axis. This is my curve. Since the coordinate of x square is negative, the curve is going to be a sad face.
So we find the x-intercepts.
Okay, it's going to be a sad face, and I want to find the area in the finite region. So I am looking to find at what? I'm looking to find this part. Okay, of this finite region, and I do not have the boundaries. Do I have the boundaries?
No.
I do not have the boundaries. So in this case, I will solve this equation first to get the boundaries.
Yeah.
Yeah. So I will factorize this equation to get the boundaries, which becomes my upper boundary and lower boundary. So my y is equal to 20 minus x squared. I'm
So
not
x is
going to
equal to
directly
4.
apply integration. I'm first finding the boundaries. This is important to understand over here. Okay. So I will take this part. I would say 20 minus x square is equal to 0. I will model this properly and I would get my x coordinates. I hope you're with me.
Yeah.
My x coordinates are minus 5 and 4.
Hmm.
Yes? Now this
Yeah.
becomes our boundary. This is the upper boundary B. This is the lower boundary A. Now, can I put the integration function? I will put the integration function. I'm looking to find the area under the curve. So, the upper boundary is 4, the lower boundary is 5, and the equation of the curve is 20 minus x square and dx. Correct? I'll do the integration normal way and I will write 4 and minus 5. Then I will find f of 4 minus f of minus 5. This will be my f of 4 and this will be my f of minus 5. Try to do it. You will get the area under the curve as 243 by 2 square units. This is how I use integration to find the area between the curve and the x-axis. I hope you're with me.
Yeah.
Okay, fine.